Hello, vintage computer friends. It's Thanksgiving weekend 2023 here in California in the US, and I'd like to introduce the final version of my project for this Busch Microtronic computer system from 1981, the PicoRAM 2090. So the Microtronic is a 4-bit educational computer system from 1981. I received this almost 40 years ago for Christmas 1983 from my parents, and I learned the basics of machine code programming on it. So it was my first computer. You would say it's a CPU trainer or microprocessor trainer, right? It has a hex display here and a monitor program, and you can program it in an educational but very high level machine code language. Very well done. So here we have the PicoRAM 2090 expansion board, which I created over the last 3 months, right? And I also participated in the Retro Challenge 2023-10 with this project, where I was still developing the breadboard version of this, and I developed the firmware and the features of this PicoRAM 2090 to maturity for the Retro Challenge. I published a couple of videos, demo videos, and video blogs, log entries, right? I also have a Hackaday page, and now this long Thanksgiving weekend, I had a little bit of time on my hand, and I was able to wrap this project up. Especially, you will now find the Gerbers, right? For the PCB as well as the firmware on the GitHub repo. So if you have a Microtronic and you're looking for what I think of the ultimate expansion for this machine, then check out the project and maybe you'd like to make one for yourself. So what is PicoRAM?
Microtronic PicoRAM 2090 ready.
So first and foremost, it is a SRAM emulator. You see that it is connected here to the Microtronics 2114 SRAM DIP socket, right? So usually the memory chip is plugged in here, but this role is now taken by the Raspberry Pi Pico, which emulates this SRAM. And that gives now, of course, the ability to basically load and store whole memory dumps from SD card, right? So rather than using the cassette interface, which is very slow and clunky and unwieldy, right? You can just load a program or say a memory dump from SD card into the machine. First of all, this is much faster, and secondly, this of course gives you file names and file browsing capabilities, etc. Good visibility, right, of your program library is always available anytime, right, rather than having to go through cassettes. So that's one part of the machine, of the expansion board, right, but it's also a multi-expansion, so it offers sound, speech, OLED display for text and graphics, and yeah, even a real-time clock, right? So when the PicoRAM fires up, it already has basically one of the memory banks that it offers to the Microtronic loaded, right? So if you see that I'm stepping through the memory here, you see that it's not empty, but that there is actually a program inside here. And stepping through the program, you also see that this display here is updated, right? So the PicoRAM knows the current instruction that the Microtronic is currently fetching from the SRAM, and it can use this to implement extended opcodes to give extra side effects to some of these opcodes, right? So for example, to drive the sound, to send a byte to the speech synthesizer, to put something on the display, etc. And the program which is loaded here, which is one of the default programs in the memory bank, right, when you fire it up, is actually a program that uses the real-time clock and loads the time from the real-time clock, which is here, a DS30 3231 on the back, right, battery backed up, and loads this into the Microtronic for display. So in order to execute the program, first we disable the display here. Then we enable so-called opcode extensions, and now we can simply run the program and we see the current time, right? So it's early in the morning, it's 5 o'clock, 37 and 14 seconds. 5 o'clock, 37 minutes and 20 seconds, and so on. So there are other programs preloaded, right? So I can step basically through the memory banks here with one of these buttons, and here we have another program which is a default program already loaded, which is 17 and 4, 21 blackjack. So you don't have to load anything from tape or enter anything, right? It's already preloaded in the Pico. And yeah, as I said, we have 16 of these memory banks which we can select here, right? And those are just preloaded programs. And also the Lunar Lander program or the NIM game are already on board, right? But what you of course really want to do is you want to create your own programs. Let me go back to bank. It doesn't really matter which of the 16 banks you select, but let me go back to bank 0. And now you see that we have now erased the program here, and we can in principle write our own program here, just as you would normally do for the Microtronic, right? So from the Microtronic point of view, the PicoRAM is indistinguishable from real RAM basically, right? So you can just write your programs as you would usually do, but of course you have all these extended capabilities and features. So let's load a program from SD card. So for example, here's a simple animation. What else do we have? ASCII display. Here's a program that demonstrates graphics as well as speech and text output. It's called the Micronet. So I select basically a program using these up and down buttons, right? And then I have OK and cancel buttons, right? So let me hit OK. So it's now being loaded into the Pico from SD card, and it's immediately available to the Microtronic to execute. So this program uses the extended opcodes and the display. So I'm turning off the display here with the cancel button, which is used in the top level menu basically to select the display mode, right? So I can toggle through different display modes here, right? So I'm turning the display off now, and then I enable these extended opcodes that give me the access to the hardware extensions with the OK button, right? So you see that it toggles between minus and star or asterisk means it's enabled, right? Now I can just start the program as normal and see what it does on the display.
Microtronic.
Yeah, a little demo program. So say we wanted to change this program, right? And save it back to SD card. So you, for example, say we wanted to put on more of these lines, these diagonals, right? There is a addition instruction, and for this, I mean, it's useful to enable the first of all, we disable the extended opcodes, right? If we program something, because otherwise you will also actually, PicoRAM will also actually execute these extended opcodes as you are stepping through the monitor, through the memory with the monitor program. And then we can also see here the mnemonics, which is kind of nice to see what's going on, right? So I'm looking for the instruction that basically adds to the x coordinates of this diagonal net that we saw, right? So there must be an add immediate operation somewhere, adding something to register 0, and here we found it, right? So 520 means add 2 to register 0. How about we change this to 5-1, so we have a finer net. So at 0b we now put in 5-1-0, and the same for the second register. There's another 5 to 1 here. At address 10, let's also say in register 1 we add only 1 instead of 2, so that gives us a finer net. And now let's execute the program again. Disable the display, enable the extended opcodes, and start it again. And now we will see that we have a much finer net, right? Because instead of adding 2 to the register 0 and 1 for these X step coordinates, right, just a double nested loop, of course, using 2 registers 0 and 1, we get a much finer net now. And of course it also takes a little bit longer. Also gives you an idea basically how fast or slow this machine is, right? Given that it's an emulated virtual machine code really that is interpreted by the TMS 1600 microcontroller, right? So it's not native machine language, which would be much faster, but you see that the Microtronic, of course, has to use the TMS 1600 to drive its whole operating system, right? Meaning input, output, keyboard, display, etc. And then also provides this virtual machine language, this interpreter, right? So the machine code is quite slow. Yeah, so we have the modified program now in memory. How about we save this to disk, to SD card? For this, from the top level menu, we can hit this button here, which then brings us a file browser, right? And I can now basically, again, using the cursor keys, create a name, right? Let's just say this is net. So to advance the cursor position, I use the next button, right? And I can also go back basically to the previous character position by pressing it down longer, right? You see it's going back to the previous position, but I'm happy with the N, so let's find the E and call it net. Now I wish I remembered. Okay, so I'm getting into the characters now. Let's just call it net and hit OK or cancel for OK to save it, right? So it's saving net.mic. And this could be much faster, the loading and saving, right? This could actually happen almost immediately, but I chose to update the display, the OLED display, to show what's going on, and this takes a few seconds then, right? So let's reset the machine. Whenever you reset the Pico,
Microtronic PicoRAM 2090 ready.
you of course also reset the memory, so we have the clock program back in memory now. And instead we want to now load our net program, which we just saved to disk, to card. There it is, net.mic, and let's load it. And that way we can execute it again and got our work back. There you go. Yeah, I don't really want to go through all the the hardware extensions that PicoRAM 2090 offers. For this, please have a look at my Retro Challenge final demo video, where I demonstrate all the capabilities. That also includes sound and text-to-speech, right? I mean, complex text-to-speech, not only uttering Microtronic, right? But it can actually read whole paragraphs, basically, and sentences. And so you can select between sound and text-to-speech, or the speech synthesizer, using this button here, this is a switch. So I'm going to reboot the machine. And now you have sound enabled, right? So due to a shortage of GPIO pins on the Pico, I can only support either sound or speech, but not both at the same time. So you see there's an indicator here in the display, S&D for sound, right? Showing you which one is active, right? So
Microtronic PicoRAM 2090 ready.
You see TDS here for speech, and let's go back to sound. So let me also show you one more program which uses the sound, right? There's a little animation that does something graphically. Again, we disable the display so it's available for the program, enable extended opcodes, and start the program on the Microtronic. In principle, you can power the PicoRAM just from the Microtronic as we just did, right? The Microtronic power supply should be powerful enough and strong enough to just power the whole board. It doesn't take a lot of power, no problem, right? And so if it's powered by the board, or basically over the ribbon cable, right? So because the 2114 SRAM has ground and 5 volts, right, VCC, then you will see that this LED here comes on, right, which is labeled as 2090 VCC. But you also have the option to power it with an external power supply here, right? Using this barrel jack. Is just a 5 volt stabilized standard center positive power supply, right? And then this LED will come on, right? Don't be concerned because the external power is not fed back into the Microtronic 5 volt, right? So the only line which is shared here basically between the external power supply and the Microtronic is ground. So you will not feed any external power into the Microtronic. You see that the 2090 VCC LED came on, right? And this is a power switch. And the LED just says, you know, you have that power source available or not. And if we change it to external power, then of course it also goes off because external power is not supplied currently, right? But I can supply it, right? Here it is, right? Let's turn it off, plug it in, and you see that this external LED for the external power supply also comes available, right? Now you can change the power to the external one and power the Microtronic like this, the PicoRAM like this. And yeah, the Microtronic is still happy. And you can of course now also turn off the Microtronic and the PicoRAM still stays on, right? So if you would like to replicate this, you have to make some mods to your Microtronic PCB. In particular, you need a DIP socket here now, right? Where usually you have a very strange white special purpose socket which hosts the SRAM chip, the 2114, so that needs to be removed. You could use a machined one, which is nicer than what I used here. And then we need one more signal from the Microtronic, which is here. So there's a via here on the board, you see these 4 resistors, right? And there's a via hole into which you can easily solder this pin header, this one pin. And that then connects to PicoRAM using this input here, which is labeled 2090 DISP. And I don't want to go into the technical details why this is required. The details are explained in the README on the GitHub project. And then of course here's the ribbon cable. So I'm using a machined socket for this, as well as a crimpable cable assembly, right? And those are, by the way, very hard to come by, so you might have to look for them a bit. But yeah, so that's the 2114 SRAM connector. Then the other components are pretty straightforward, right? I already explained the TDS or sound switch, the power switch and the power source switch. An expensive part is of course here this speech synthesizer board from Micro the company Microelectronica, which hosts the Epson DSP running Deck Talk, right? A very nice speech synthesizer, but also $50 basically if you ship it, import it. And the OLED display, so this is an I2C OLED display. Again, the whole list of components, the bill of material is on the README on the GitHub page. Then here we of course have the Pico, which is very inexpensive, right? Here's a PAM audio amplifier board. driving the loudspeaker, right? You can just connect any little loudspeaker of your choice. Then we have the Adafruit micro SD card module here, and you know, a volume potentiometer, just some caps and resistors, the LEDs, and on the back also the real-time clock, right? Battery backed up real-time clock. It's a DS3231. So you can get 5 of those basically for $10 on Amazon. Yeah, so that's the board, and as I said, the GABAs are in the firmware you'll find on the GitHub repo. I also have the legend for the buttons here, right? So the button labels are indicative of the functions that they have during file selection and file name creation, right? Like up, down for scrolling through the list of files, right? Next and previous for the next and previous character. When you create a file name, OK and cancel are clear. Reset is clear, of course. And so here you find the button label, right? As well as the primary and secondary function. So primary function is listed here. For example, from the main menu, push to the up button gives you a load menu, right? Push to the down button gives you save, and so on, right? So select RAM bank, a number, external opcodes on and off, display mode, and then this is the secondary function. So if you hold them down basically for half a second, instead of pushing them shortly, you get the secondary function. And for example, you can say the time using the speech synthesizer, you can show the time, the real-time clock time on the display, and you can set the time, right, and test sound and list the files on the SD card. So these are the functions which are listed here in the button legend. And yeah, so that's about it. I guess it costs about $100 or so to get all the components and the PCBs produced. I'm using JLCPC. And yeah, those are basically just isolated resistor arrays, right? So in principle, we found out that the Pico does not really need voltage dividers or resistors or level converters to safely interface with the 5-volt TTL levels of the Microtronic, right? But originally, and to play it safe, I had the concern that we should really bring the 5-volt levels down to the Raspberry Pi Pico's 3.3 volt levels, right? And this is what these isolated resistor arrays are doing. So, but if you are comfortable with, you know, driving your Pico with 5 volts, right, you can also short these out basically and just create bridge wires instead. Alright guys, so that's about it. I think I covered everything I wanted to cover, and yeah, so thanks for watching, and yeah, check out the project on GitHub, and if you have a Microtronic, then I think that might be the expansion board for you.